next up, we are going to hear something about open source options for FPGA. So in the presentation from ULX3S to modular ULX4M from Goran.
So hi to all. Today I will present, when I get the picture. Yes. So I am Goran from Zagreb, and today I will present some stuff we are doing in Zagreb, mostly related to open source FPGA stuff, but there are some things that we are doing like out of those. So I spent like 15 years as a repair technician, and that experience helps me now a lot when I'm like designing hardware and doing software. I am co-founder of Intergalactic, the company that is selling those open source boards, and the company was founded actually from the Radiona, my makerspace. I am in the makerspace for about 10 years or so, so we are doing lots of different stuff in the Radiona. I will show that later. So Radiona is a non-profit also, it's NGO, we do lots of different stuff, so it's like a combination of makerspace, hackerspace, so we hang around there doing like lots of art stuff, lots of electronics, lots of exhibitions for the museums, and having lots of workshops and many different things. And like Radiona is really the place where all different people gather. So we have lots of people from like doing electronics. Some people are like from the art sector, some are from like designers, and then when we do some work, we usually combine like things from that. So we have lots of different types of workshops. This is from one workshop that we are doing like robot fights, and we are using like old trash, something like vacuum cleaner and like something to get robots. And yeah, people like to hang around in Radiona, and we have like around maybe two workshops per month. Most of them are like from external lecturers or teachers, and some are like internals. And once a month we are doing like repair cafes, because lots of us is also related in this repair stuff, like Mario is here, Zvone, they are also repair technicians, so we are doing it like, and we are not doing it like that we are repairing, we are just, people bring their own electronics and they just say, this is not working for me, we just check like what would be the next step and give them the tools and explain what this device is doing and how it is working, and they actually repair the device themselves. So that's the idea, not that I'm working there like a technician repairing stuff, but to actually show what devices are doing and show how to repair them to others. And yeah, most of my talk will be related with FPGAs, and like FPGAs have some like complex explanation, but if we want it like oversimplify this explanation, so FPGA would be like to having enormous amount of like switches inside of some chip, and you can like put that switch on or off and get some electronic design inside of this FPGA. So you will have the inputs and outputs, and all signals will pass through this logic, and you will have the end logic at the end. So, and you can do any digital logic inside of the FPGAs. FPGAs consist of like many things, and some have like, you probably know that some already have like microcontrollers, but the one we are using, it doesn't have microcontroller, but it has some memories and some other stuff inside. So when you're doing like FPGA design, you are not writing code. You are actually doing it like on the breadboard. So you are like having modules, like the chips, and you are describing those modules. And when you get finished, like on the microcontroller, you will get you have like firmware, but here you actually have the bit stream that is like describing what the hardware is looking like. So actually bitstream is description of the modules inside and description of the hardware. So you are not writing, like it's not sequential code, it's just everything is happening in parallel, like on this breadboard. So you have just USB input and lots of modules, or here are the chips. And also the language, all languages that are describing the hardware are called like HDL, so hardware description language. And there are many languages. Most used is like Verilog or VHDL, and nowadays there are like lots of more things, like now we can also do things in Python or something. But in any language, like we are doing it, describing the hardware, not doing like programming on usual. So this is just a little bit of the history of the ULX3S. So this is the board like here, so you can see the size of the board. It's like done in collaboration with Faculty of Electronics in Zagreb. So at one point we had like some workshop with Arduino, and Marko Zec arrived at our workshops and do some like simple things like controlling the OLED displays and some button switches. And he already designed the ULX2S for the university to teach students about digital logic. And when he saw like how simple Arduino is, he talked with the Davor, is this maybe possible with the FPGA? So they actually started to work first on the FPGA Arduino. So it was like some core, like RISC and MIPS core inside of the soft core inside of the FPGA, and it was just controlled from the Arduino. So we could like put some Arduino programming inside of this core, and it ran. And after some time, they started to talk about how this ULX2S board is like, it was old, it used the smaller FPGA, so they started to develop the new one, like ULX3S, and adding more things to it. So because the old one like was like here, and it didn't have like not VGA, not many things that I will show later. It only had like a video output, like on one pin for the like BNC, and it had audio output, SD card, USB, few buttons, and few LED switches, and that version was with the SRAM. So SRAM is quite easily controllable with the FPGA because it doesn't lose the state. So you can like program, you can put something in the memory and it doesn't lose the memory. SDRAM is a bit different because the memory is lost, so you need to actually refresh it constantly. And so Emmer started to work on this, and after a few years, it was all like more like hobby project than university project. So it was like we are helping from all the sides, and we have, like we suggested something, he moved something, and we started after a few years when it was like completely done, we started to do a crowd supply campaign, and after that campaign we actually sold lots of boards, and lots of community started to work on different types of project on the board. So the ULX3S, the main chip on the board is Lattice ECP5, and so there are different types of those chip, and ULX3S is supporting Almost all 385, I think it's 3 something, so around 381 pins, and it is supporting all of those 381, because some pins are like, in datasheet there is one thing like do not use this pin, break it to ground or something, but Emmer discovered that he can use pins and he can use just like common pins and get those pins out, so we can use like any type of those. We have like, it has lower, FPGAs are all about like memory and how many gates they have, so we have like version with 12K of gates to the version of 84 gates, and actually most of the designs we are doing can be fitted in those 12K, but the most sellable board is 84K for some reason, because people always want like quite a big board, and whose biggest is better for them. So, and this board can only go with its big B, it's up to 64 megabytes. We can place different types of SD-RAMs. We have checked with lower versions and different manufacturers. It all works, so it has the SD-RAM controller, SD-RAM chip, and it has 2 micro USB connectors. So the first connector is connected to the FTDI chip, and then FTDI chip is connected to the lattice, so we can actually program the FPGA over the FTDI. We also use this FTDI for the serial interface, and the second USB is connected directly to the FPGA, so we can use it like for the host, or we can do some different things on that second USB. We can also do like, we can also have USB bootloader on this second USB port. So we have different types of programming this board. So we also have JTAG pins. We can program it over the JTAG. And on this board we have placeholder for the small OLED display. So it's like, I think it's SPI, SPI OLED that can be fitted on the board. We have micro SD card. It's 4-bit. We are using just 4-bit 4-bit communication, or SPI for the SD card. We have 8 LEDs, and like 8 was the idea was to represent like 1 byte. So 1 byte, so 8 LEDs. So when the problem is when you are debugging actually the FPGAs, you don't have like something like step-by-step instructions, so you can get like stop and get something back. So most of the time you are using sometimes like you are using the LEDs for the debugging. So so you can attach the signal to one LED and you can check if that signal is changing. Does it get there? What does it do? So LEDs are quite important on development board for the signal checking. And we have the next thing, we have like, it's video output, and there is a really bad problem with the HDMI is proprietary. If you want to use HDMI, you need to comply with the regulation and you need to pay a lot to get the HDMI on the board. So we are using the HDMI connector, but we have called that thing the GP, general purpose differential interface, and it's actually using the DVI signal. So DVI is free and it can be used. So we are using DVI signal, but most HDMI monitors are actually familiar with that signal and they can like show the picture. So it's almost like HDMI, but it is not. On the board we have the same connector like on the ULX3S, so we have it, it has 3 pins, so 2 pins are for audio, it's 4-bit audio, so it's just a simple resistor divider, and one pin is also like the video pin or for whatever, so we can have like BNC video out on the board. we still like the ULX2S had like good idea to be like the like a controller. So on the ULX3S, actually we imagined that it would be great if it will be like you can hold it and like you have it like a controller that already have everything inside. So that's why we have like 7 buttons around the board that are put like the controller. Also, yeah, some deep switches are, you can always like, when you are doing some design, you always have like something you want, like when the something good, you want to check if you want this or this, so deep switches are quite useful. We also have some simple ADC on the board because it was like Arduino has always those potentiometers and stuff, and some people want to experiment with ADC. It's not super expensive or super quality ADC. It's 12-bit ADC, but 8 bits are useful, and it is differential. So I think it has four differential channels or 8 single-ended channels for the ADC. Board has 3 power supply, so that's how the actually FPGA's request is like to have 3 power supply. So it has 3.3 volts, 2.5 and 1.1, but for the like 1.2 you would need for if you use the chip that has 5G like SerDes. But on this board, those SerDes pins are, we have just few pins out on the OLED display, but we never use them on this board, on the ULX3S. This is the FTDI chip, so it's just doing the JTAG stuff and USB serial, nothing super special. And when the FPGA boots, it doesn't have like any information inside of it. It needs to take the information from somewhere and then actually have that design, put that design inside. So for that we have a flash. So board is actually booting from the flash in some way. So when it's powered, the FPGAs take the bitstream from the flash and then it's loaded inside. We also have like some special features on the board. One is RTC and low power thing. So we can, if we are using like RTC, we can put the battery inside just to hold the clock without the power supply. And we can actually set the timer to wake up the board and then power off the board so it doesn't consume, it consumes really a low amount of energy. It's like 10 microamps or something, because nothing is working actually, just the RTC is working and controlling one line that will power up the board when the time when alarm is set. On the board, so we wanted to have some like microcontroller so we can like exchange some information with it, and like ESP was most popular, and it gives us lots of options because it has the Wi-Fi, Bluetooth, so it's like quite a cool option for the FPGA board. We also have software for the currently on the ESP we have MicroPython because it's easier to write programs for it, and we also have the programs that ESP can program the FPGA. Because Emerd always loves to work like on some remote project, so it's like we can like access it remotely over the FTP or something, and we can just send a new bitstream and board will have a new bitstream on it. So the latest version is this. So this is how it looks. From 3.1.4, I think nothing, for 3.1.8 nothing special did change. We're just changing like some simple stuff like adding the filters on or something, so nothing spectacular did change. And the board is completely open source from the start, and it is on the, you can just search ULX3S on the GitHub, it's Emerd ULX3S. And top side of the board, I already explained all those things, but this is like how they are placed. We have few more LEDs that are like describing when the serial port is doing something or something. is done on like power LED and we also, so the maybe one important thing is like we have those jumpers on 3.2, 2.5. So FPGAs can have like, you can set the banks. FPGAs is splitted in some banks, and those banks holding some pins. And left bank voltage can be changed with the changing of those jumpers or resistors. So you can add your own voltage to those pins, and you can get like whole bank to work on like 1.8 volt or 2.5 or 3.3 volt. Yeah, this is the bottom side. I think I told everything about this. Yeah, we have lots of pinouts. Some are differential, some are not, some are single-ended. And yes, the whole board is designed so the pins are designed to be like PMOD compatible, so we can use PMODs on this board. And yes, we started the campaign, and campaign was really successful. We didn't think that it would be so popular, so it was like our goal was like 10 times, and we got to 10 times more, and like we delivered last year we delivered all the boards. So we first formed the company, then got money, and then we bought everything needed, and then we started to preparing like production and everything. And the complete production of the ULX3S is done in Croatia. So it's so we have first batch was done by Končar. So we had some deals with them. So they did 1,000 boards. 1,000 boards. They did it. They assemble it in Končar, and after that, so for this, they do just big batches. So after that, we switch to smaller companies, but they are also in Croatia. And last batch is from Drivers and Motors. They are in Istria, and they are doing like batches of 100, 200 boards, and they are doing actually the first boards from the Končar. So I bought the parts, and they assemble it, and now the Drivers and Motors are doing everything. So they are. I just tell them I want 100 or 200 boards, and they are actually buying parts, and they do complete assembly, testing, and packing. And this is a video from the campaign, because there is lots of things around this board and lots of projects, so I don't want to talk that much, so I will just start the video from the campaign so you can see it live if it's working. But maybe I can put the sound out. I don't know why it's not. Just a second, I will try to get the sound. Jel možda kod tebe sound? Evo. Da. Okay. Čisto imaš? Evo. Jel imaš? Ja ti to imam. Neki čudni. So yes, you saw we are using the open source toolchain, and big thanks to Yosis HQ for this, because yeah, it was like our board would never be so popular if we are not using the open source toolchain. So the Lattice has its own tool, it's called the Diamond, but yeah, for us using the open source is like priority. And yeah, after campaign we needed to, because NGOs in Croatia cannot sell the board, so we needed to open a company that will do the distribution. And after that we started with like doing other things, and with like all those projects are always open source. So one of those projects was like Firefly, that just one it's just a simple board that is doing something like we have our own protocol, but like similar like DMX. So we needed to cover one big museum with some lights. So those are all like controllable RGB lights, and they are doing like presentation of stars and like something, water, something, but it's like completely custom projects made from zero to finish. I'm also helping the Paul with the megaphone project, so it's like also a completely open source project. And after those batches on the drivers and motors were finished, actually first batches and the Concher, when those were finished, Concher didn't want to do the testing of the board, so I did that by myself. And you probably know Dobrica, he is often guest here, and he did some scripting and did some like batch testing for me. So he programmed some scripts for like programming 10 boards. Like I'm just plugging the USB, and those boards are just getting all tests done and everything. So it's quite a light show when I'm doing that. But after that, I was talking to the production companies, and they always want like scripts. For me, scripts are really cool, and I can do everything in scripts. But when you send the boards to some company that is producing the board, they are always like, they like GUIs. And so I talked with Envox, so that's also the company that is doing all open source hardware and software. And for me, they just checked the scripts, and they had new thing, like it's called Easy Flow, and they completely redesigned the testing scripts. Now we have like complete GUI for the batch testing of the boards. And they are actually, those flow is part of the Easy Studio. It's also open source project, and it's really huge and enormously good project. It's so they are doing like the modular power supply. So it's fully a modular power supply, but they started, so when you're designing some GUIs, actually if you start to write the code and if you use some proprietary GUI thing, it can change, and yeah, it is quite complex. So they actually started to build the studio for designing the GUIs. So they actually built first, they wrote the Easy Studio, and then in the studio they actually designed complete GUI interface for that power supply. And inside of that studio is also controlling of the measuring equipment, so you can control any with Skippy command, you can control any measuring equipment. And then actually they they try to, like if you want to automatize something with the measuring equipment, then the best way was to design this flow. So you can use the graphical interface and some nice flow graphics to avoid like direct programming or direct scripting. And I have latest thing they have, like they support different types of boards. So this is like my something with their studio. So I designed like just a simple flow that is doing some button things, and I press the reset instead of the button. But yeah, so it's like like I can control hardware, and I did everything in the GUI. So it's quite cool open source project. And as for the ULX samples, there is enormous amount of samples and enormous amount of things people do. As you saw in the video, it's like retro computing, retro gaming, some security stuff like the something SPI, it's somewhere here. Yeah, the best startup point is like ULX3S GitHub IO. So we have the list of the most of the projects we can find, and we change that list often when something new arrives. And that startup gives you like the links to the EMARD, like simple design. So every piece of the hardware is actually already supported. So so you have like PS2, USBs, audio, SD-RAM, DVI, whatever we have. We already have startup points for your projects. I'm also designing like open source. Not every is PMOD compatible, but the boards like extension boards for the ULX3S. So because on the Oberon project you saw that one, I need like 2 USBs for the mouse and keyboard. Also for the Minimig like Amiga projects, I need two controllers, like 2 PS2 controllers. So I designed this USB to have actually 3 when I plug this in. And we designed this GPDI input-output PMOD, so we can have like something like DVI input, but the problem with the input with DVI input is that you need to like synchronize all the signals that are entering into the board. So we are still synchronizing that with moving phase on the like red clock and something, but it's not super high resolution, so you can do like 640 by 480. So it's just a simple proof of concept that we can do like HDMI input, then some overlay on the picture, then put the picture out on the second GPDI. And this is like simplest thing. It's like OV7670 camera extension board. It's just we can support like 2 cameras on the board, and you can get picture from both of those. And yeah, boards are sometimes available. Unfortunately, this chip shortage is like killing every hardware thing. So some boards are sometimes available on Mouser and sometimes available at NVOX store. But now I also have problem with like EMC and stuff, and I need to certify the ULX3S. So currently you cannot buy, if you are in EU or UK, you cannot buy the boards from Mouser. You need to use the NVOX store. And yeah, story with NVOX, like we started to talk with the batch scripting and something, so we wanted actually to combine. So so they have like powerful power supply, and we have the FPGA. So we wanted something in between. So FPGAs can do like a lot of more signal processing, and so we had an idea to combine those 2 things and to get something out of it. So we started to work on one project that was actually combining the FPGA and the STM. And on this project's STM picture is overlaid on top of the FPGA picture. So we can do like everything that they have, so complete studio and something, and we can overlay that on top of the like Scopio project you saw. So we can have like something like open source oscilloscope. But the main problem here was like especially today, some parts are not available. So we had lots of problems to buy like STM. So, and we have lots of problems to build this board. So we designed it, but now it's problematic to get. So we decided to go actually modular, to have like modular board. And that we can, when someone asks us to combine projects and something, we can like just use our modular board and just use the pinout for, just do the pinout on their design or similar. So we are collaborating in many projects, but the most important is probably this sandbox stuff. And yeah, we wanted to actually to have simple pinout with all pins out, and we have checked like what are the possibilities, and we needed to switch like onto 6-layer board, not 4, so everything like gets more and more expensive. So we asked the NLNet Foundation if they would like support us and to have multiple modular boards, and they said yes, they will, and they are supporting us also right now to do different stuff with those modular boards. And inside of this support grants, we also have the opportunity to experiment with Blender, so we can combine like art and electronics. So this is from Blender. So Paula from Radiona is doing all the Blender things. So we started with the simple things and then doing like more complex first pictures, then videos. So we will probably use these latest videos in the new campaign for the small board. So this is also like the picture from the Blender. So we can use that. It's also cool when you have like ideas or something to have the board first in like virtual environment, like in Blender or FreeCAD, so you can just check the dimensions of the board, because this board is having the really small like connectors. And first thing we had, like before we started with the Blender, I had the problem like 1 millimeter board was 1 millimeter off so it wasn't like clicking on the board. And yeah, we started to experiment in checking what would be like proper connector for our stuff, and we checked a few connectors, and like we saw the connector that is used by the Raspberry Pi CM4 connector, and it was quite cheap connector, so we decided to go with that one. And also when we started to work with that connector, it would be stupid to not to use actually the CM4 pinout. So now we are actually doing the board that is actually CM4 compatible. So we can use any base board that is actually Raspberry Pi CM4 IO compatible. So that's the good feature for this board. Yeah, this presentation is a bit old because now the versions are, I am now on the ULX4M. So there are two versions, like LD and LS. LS version is SDRAM, so because we want to preserve compatibility to ULX3S, and SDRAM is mostly used in retro gamings. And some things are even like probably not possible with the DDR memory. So we are still preserving like the version with the SDRAM, but we wanted to add more to a new board. So a new board will also have the option for the DDR3 memory, and that board will also have those SERDES pins connected to connector. Yeah, I don't think this is like the newest. So now we have on the board, so this is the newest, this is the LDV2. Now I'm doing V3, I'm sending the design of LDV3 and the LSV2. But now we have like LEDs on the board, like 3 buttons. We have the 1 gigabit Ethernet chip, and we have the, like I added the USB connector so it can be used without the baseboard. So that was a request from the users. Yeah, the important stuff is what we want to experiment with. It has the connections to the CSI for the camera interface, so we can control 2 cameras on this board, and that's quite important if you want like stereo vision things and like to get pictures from the cameras and to put pictures in the DDR and to do some math on the pictures. And we can support one, I will see if second is possible, DSE, so for more display, and we have 2 DVI outputs. We have PCI Express and yeah, lots of different things. And yes, this DDR3 actually is latest work is actually supporting fully open source Linux, so we can actually boot Linux on it. And yeah, those are the layers on the. It's quite dense, and it's even more dense now because I add, like step by step, I'm adding some features to the board. So board has like three signal layers and 2 ground layers and 1 power layer, and it's like those are just signal layers, so those are 3 signal layers. Okay. And yeah, we are compatible with all CM4 base board, so there are lots of boards out there that we are compatible. So here I have like something like GPI case 2, so it's ULX3S inside, and it's completely like doing the NES emulator, and it's actually the like completely like handheld devices with just our board and the case from the internet. It's also, we also are talking with like QTPy tablet. They want to use our board for the tablet. So, but we need to support like those DSI are really crazy. Yeah. So I have tested, and I can get the picture from the camera. That's like a CSI MIPI thing, and those tablets are using DSI. Screen, so DSI is quite complex to do in hardware, and I think it's some part of those are proprietary, so we will need to check how to get the picture on the LCD. I'm also doing some like experiment with the Balthazar Foundation, so they want to create some like open source laptop. Something like MNT Reform, but they want it like simpler. So the idea is completely to simplify it, and so I'm doing the design so it can fit the ULX4M or CM4 module. So the user can choose between those two. And yes, this is actually the booting of on the DDR3 memory. This is the booting of the Linux. So it's not super extremely fast, but it is like down to last transistor open source Linux boot. So that's the important part. It also has the frame buffer, so we can push something in that frame buffer. I think I don't know. Yeah, I'm just copying some image from the SD card to a media, so I can just push the picture to a frame buffer. Nothing super special, but just shows that frame buffer is working well. Yeah, so that's shown on the HDMI port, so you can see the picture on the. And it can also have the X, but it's like, yeah, it's proof of concept. It's not like you will run Debian soon on that, but you can have the X. And yeah, you can run Doom. That's the most important part of the thing. And yes, that's it. So here are like my contacts. We are on Jitter, Discord. You will find me, Radiona or like Intergalactic. We write article for like AnalNet. For each grant we write one article, so you can check the news on the Intergalactic. We have like everything there. So Blender stuff, all the designs of the ULX4M, and everything we do is like in the news channel. So thank you. Yeah, questions? No.
Are there any questions? Yeah.
Hello, thank you for your presentation. It was very nice. So 2 questions. First, is the ULX3 available? I see it kinda is on the crowd supply page, and how that actually works now if I want to buy one. And the second one, you gathered a lot of money for your crowd supply, and you had to like make a company in your country. So did your government let you have all your money, or did they took some taxes there, and how that actually works in practice?
Yeah, thanks. Yes, boards are available on Mauser, Crowd Supply, and Envox, but on the Mauser and Crowd Supply, they will not ship to Europe. So that's the problem. Because we are not, we didn't sign those EMC thing with, like I need to do the measurements of the board, and measurements are expensive. So that's the thing. And for the money, yeah, you will get taxed for everything in Croatia. So yeah, we received, so there is no tax. I received like money in advance, so they don't tax that. So you don't like need to pay tax on that. But when you sell the board, then you will pay like, I think it's 10% if you have some profit on it. But we are like low on profit. We are not extremely profit, because I am working there alone. I'm getting just my salary, and we are not like extremely profitable. We are sustainable, but not extremely profitable. So it's not so much of the tax. So most of the things goes on like my salary and tax on my salary. So it's not so bad. But at the end, so we calculated like we wanted. It was still like those prices are look really high. But from those prices, we calculated that we need like 20% of, get 20% of those. But the latest like results show we get like 7% from one like selling. So it's not, it's actually nothing. So it's like but main, actually for the company, we don't have like hardware selling as a main thing. So we are actually selling the designs and work on designs, and that's the main thing on the company. So like also we get money from the AnnualNet for the research and development. That's the like that's really cool thing, and I'm getting paid for like things to do with other open source projects. So that's the main income in the company is from the service, not from the selling of the hardware. So yeah.
Any more questions?
No one.
Yeah. No?
Okay, just one more thing I forget. So this year we will probably have the campaign for the ULX4M. So we will have 2 versions. One will be like cheaper for retro gamings, and second will be probably extremely expensive, because just the chip is now, I think, 80 euros. So just the ECP5 with Cerdes 5G is like at around 80, 85 euros. So, and Lattice doesn't give the discount for the quantities. You have like few bucks lower, upper, but it's like you can do many boards, but you still need to pay for those ACP5. And the main problem is that ACP wait time is now 1.5 years. So you need to pay everything in advance and wait for 1.5 years to do the production. Then you can like sell the boards and get the money. That's the current hardware problem, yeah. But yeah, thank you.